Questions 13 and 14 are about symmetry. Number 13 is about line symmetry. So this is the one where if you can fold it in half, it will be the same. These Greek letters, this one's a uppercase pi. You normally see the lowercase pi looking like that. That's an uppercase pi. Lowercase pi is not going to have any line symmetry because it's different. It squiggles up here, but this one has some line symmetry going this way. Because it connects on top and doesn't connect on the bottom, it won't have line symmetry that way, but that one has line symmetry, so I'm going to put that one here. This is the uppercase sigma, and it has line symmetry here, so I'll make that symbol right there. And then this is the beta symbol. It's where our B comes from, and our B, if you do it correctly, will have line symmetry here. Now this one doesn't because my bottom hump was a little bit bigger, but if I would make those the same, then we could have line symmetry here. But you can see that this little tail here makes it so that it's not symmetrical. And then this is the lowercase delta symbol, and that is not symmetrical either. If this would connect and look like an 8, it would be symmetrical two ways, but it doesn't, so it's not symmetrical. Interesting thing about the Greek alphabet, there's uppercase and lowercase letters. This is beta. The first letter is alpha, and that's where we get the word alpha, beta, alphabet from. Okay. It's also where we get a lot of our letters from. So number 14, quadrilaterals. Which of squares, rectangles, and trapezoids have rotational symmetry? Rotational symmetry is the one where if you spin it, it will be the same thing. So this is a rectangle, and if we spin it, no, that's not the same shape, but that is. So if you rotate a rectangle 180 degrees, it will be the same thing. For a square, now you'll have to imagine that this is a square because I don't think I'll be able to fold it exactly right. But if I were to be able to fold it exactly right and this were to be a square, then it would have rotational symmetry of 90 degrees. You just have to make a quarter turn, and it would be a square, and same square, because all the sides would be the same. A trapezoid is one that goes like this, and on purpose I made this angle and this angle different. So if I rotate this one 90 degrees, that's a different thing. If I rotate it another 90 degrees, it's a different thing. And so it has rotational symmetry order 1, or it has no rotational symmetry. So for number 14, it's just squares and rectangles. So on the test, when you do rotational symmetry, just imagine spinning the things, and line symmetry, imagine folding it over.